back in at the beginning of this unit, we talked about scatter plots. I mean, we said that we have different variables. We want to relate two variables. We're gonna plot the points because graphs are a good way of conveying information. It's a good way of basically looking at your data and making conclusions and seeing patterns, right? And there's a saying that says a picture speaks 1,000 words, right? So it's always good to be able to visualize our data. One specific type of relationships that scientists are very interested in is the relationship between distance and time. Okay, so we call them distance-time graph. So, for example, if I'm walking at a constant speed, right, I want to know, like, after, for example, 3 seconds, how much distance did I cover? So this time is my independent variable, goes on the x-axis, and distance is the dependent variable, goes on the y-axis. So it's a very good tool, a very good way of showing information that would describe your motion. That's why it's important. Okay. And later on, if you take physics or get into grade 12 calculus, you're gonna also do velocity time graphs and also acceleration time graphs. Okay. But for now, we just focus on distance time graphs. Okay. Now let's look at a couple of examples. We're gonna first look at a swing ship at this is not like Canada's Wonderland, but a Wonderland has a similar ride. I want you to look at it and then tell me which of these three graphs show how the height of a person that's riding this ride is changing over time. Okay, so let's take a look. That was Joanna. All right, so you get the idea. So which one do you think it is?
The last one.
The last one? Okay. So do you guys agree with the last one? Does anyone have any other ideas? Last year? The second one? Okay. You guys, so now we have two options. Anybody thinking it's the first one? No, I think the first one? Okay. So let's see it. Can you tell me why you're saying it's the second one?
When the ride begins, it starts off in the middle. It starts off really low and then it goes higher and then back down and higher and back down. Each time it goes high, it goes higher than the first time.
Okay, very good. Okay, so, and that's good. The third one showing how the motion looks like. Let's keep going like that, right? But remember, the question didn't say how the motion looks like. The question said which one describes the height and how the height changes. Okay, so that one doesn't show it because it shows that you're starting high and then you go low. You go becoming high as time goes by, and it's just one swing type of thing. The first one is kind of a pendulum. It's saying that you went higher, then you come lower, and you come higher and lower, and you keep going that, right? So it's like a pendulum movement. And that wasn't the case here. Because here you started low, as Lassie put it, right? You went higher, and then as time went by, you went higher and higher, and that's what is showing to the middle here. But then the ride is not going forever, and you're not going to get higher and higher forever. So it's need to kind of slow down. It's going to get lower at the heights until it comes to rest. So the answer is the second graph. Okay. Now let's look at next one. This one is drop tower at Wonderland.
of all guests and employees. The company is participating in transportation that is not a designated smoking area. A designated smoking area is usually located throughout the car and are clearly marked on all park maps. This is a nice one on
All right. So which of these three graphs do you think?
I think the second one because it shows that like for when it rises up, it kind of takes its time because it goes really slowly, and then it stays at the same height for like a couple of seconds, and then it abruptly drops.
Okay. So anybody else have an idea, Flora?
Well, not the first one because it kind of shows like the time. It goes up, you stay there, and then it goes like down like the same time. And the second one, I feel like it's not that one because the time would be at the same like second or minute. So I don't think of it like that. So I think it's the first one because it like
Third one.
no, I mean the third one. Sorry, because the time kind of like goes steeper. So I think it's that steeper.
Okay. Good ideas here. Let's have more. You can add to that.
Okay,
Session.
so it goes slow up, and then when it's coming down, it goes down, but then it stops like 3/4 down, and like it just slowly goes down, and it's like a drop there.
Good. So the combination of these explanation makes sense. So let's see why Joanna's explanation. Joanna's choice is not really the best choice. Okay. So all of these have the beginning part the same. So it's the same steepness of light going because it's your they're taking you up, right? And it's going as a constant slow speed. You are enjoying the scenery. It goes like slowly going up, gets up, and then it stops. The time goes by, but you are not changing the height. That's why it's a horizontal line. Because they're building that tension. They're building. You're swearing at yourself and say, "Why did I do this? Why did I make me do this?" You go to your friends. I didn't want to do this ever. Like I hate myself. I hate you. So you start going like that, right? Because you don't want it, right? And then they let you go. Okay, the moment's gone. So this one is not. It shows that, as Flora said, it's going down at the same speed as it was going up. Like, what's so fun about that? Like, there is no excitement in that. You're just enjoying scenery. So nobody likes that, except your grandma, maybe. Okay? So that's no fun. Okay? Second one. Let's see what's the problem with the second one. The second one, yes, it's very abrupt. It shows that there is no time passes from the time that they let you go and the time that you came to the ground. And you're hitting ground like boom, dead. Okay? No good. Not gonna work out. Right? I don't want to be on that ride. Okay? The last one though, it shows that they let you go. At the beginning it's slow and it speeds up. The gravity pulls you down. So it speeds up, so it becomes very steep, but then they have to put the brakes. They have to slow you down, or you'll hit the ground with that fast speed, and you may rest in peace, right? So that you don't want that. So you're braking, so you go slow down, and then you come to stop. Okay. So the answer is the third. Okay. All right. Now I want you to look at these. There are three containers. Okay, you see them generally in a science room. And we are basically pouring water in each of them at the same rate, and we want to know which graph represents which one. But before we get there, what's the name of each of these containers? What's the name of the first container here?
Graduated cylinder, I think.
That's the first time I'm hearing it.
No, hold on.
You said that. Somebody said that. I heard that.
Beaker.
That's not the
That's the
beaker.
second one.
Beaker is the second one. This is beaker. I keep hearing it. Flask. Okay? And the last one? It's a test tube. Okay? So take a moment, say which of these graphs correspond to which of these containers, and we'll take it up. Okay, which is which? Okay. Very good. So exactly. So both beaker and the test tube, they have the same cross section throughout. So if I'm pouring the water at the same rate, it's going to go up at the same rate, at the constant rate. So it's going to be linear. Okay. So we know that these two going to deal with the beaker and the test tube, but the flask doesn't have the same cross section throughout. So at the bottom is wider, so it takes longer to get the level go up. But as it gets near the top, it becomes narrower, so it go up faster. So that's why the second one is a flask. So it's a non-linear movement, the change in height. So that's how it looks like. The beaker is the last one because it's a wider cross section. It takes longer for the level to go up. So that last one is going to be the beaker, and the first one is going up faster. Therefore, that's your test tube. So whenever we want to show a faster movement, we are using a steeper line. Whenever we want to show slower, it's going to be less steep. And as we saw in the previous example, if it's stopped, it's going to be a horizontal line. Okay? If something is speeding up or slowing down, so it's not going to be a constant rate, then we are going to have a nonlinear graph. Okay, curve. Okay? So now let's get to actually the time distance graphs and see what are the expectations. So generally in this type of scenarios, I either gonna give you a graph and ask you to describe the motion for me, or I'm gonna give you a scenario and ask you to draw the graph for it. Okay. Some of these scenarios gonna deal with a motion sensor. So you generally might hear the word CBR motion sensor. That's just a device that shows you how far you are away from an object, for example, from the wall. Okay? And in these contexts that you have, for example, distance of 2 meters and your time is in seconds, generally those are the scenarios that we're going to describe using the motion sensor. Okay? These are the information that I need you to include whenever you are describing a motion. So you're going to talk about your starting point. So where are we starting? You need to tell the direction that you are going. Okay, so are you going away or are you going toward? That needs to be included. And also the rate that you're going, the speed. How can I find the speed? How would I find that? Okay, did we learn a concept that helps us with that? To see how much my y changes over how much x is changing? Slope, very good. So I need to find the rate of change or the slope, which shows me the speed, essentially. So 3 things that you gotta make sure you include. Starting position, which direction you are going, and the speed that you're going at. Okay? And you need to also, like when you're talking about that, you gotta add some words as, is it, for example, walking? Is it jogging? Is it running? Are you on a bike? So based on how fast you're going, especially if it's multiple sections, you gotta use those words as well. So let's look at part A here. I want to describe this motion. So we said that we got to tell the starting position. Where am I starting? Two meters. Okay, so because the graph starts at the 2 meters. So starting 2 meters, let's say from the wall or from the sensor, whatever. Now, we said that we got to say, am I going away from it or am I going toward it? What do you think is happening? Very good. It's away because my distance is increasing. If you look at my y values are getting larger and larger. That means my distance is growing. So I'm going away. So I'm going to use the word walking. So walking away, and away is an important word here. I must include it. It's a straight line, so it's a constant rate. So I'm going to say at the constant rate of, or constant speed of. Now I have to calculate my speed. So speed, rise over run. So I have to pick 2 points on this line, see how much my rise is and how much my run. And remember, we said always count the units, not the squares. So you gotta make sure you look at the scale. Here it happens that my scale is showing each square as 1 unit. So this is going up 2 units, so that's a positive 2. And going right 2, so that's also positive 2. So my slope is 2 over 2, which is 1. And what would my unit be here? Because I'm dealing with a rate. Meters per second. Speed, right? So distance over time, meters per second. So here I'm going to write this so at a constant rate of 1 meters per second. I want all of you to try part B, and then we'll take it. So what do I say here? Adam?
Starting 8 meters from the sensor.
Okay, let me write this. So starting 8 meters. Starting 8 meters from the sensor. Okay.
Walking towards at the constant speed.
Very good. So it's going down, so it's going walking toward. So walking toward it, towards it, at the constant rate of, now I need to find my slope. So what's my slope here?
I got negative half miles or meters a second.
Okay, is this negative half? Is it positive? It's going down, so it is negative. But is it 1 over 2 or half? Negative 2? No. It's negative 1. Count units, not squares. So here, the scale on the y-axis is going up by 2's. So each square represents 2 units. So this would be 1, 2. As I'm going down, that would be a negative 2. And then here it's 1, 2, 3, 4. So that's 1 unit. Sorry, that one was there, right? Negative 2. I say each of them is 2. So that's negative 4. Right? So 2 squares, which represent 4 units. But my x-axis, my independent variable, it is going up by 1. So that's going to be 1 each. So it's 4 units. So my slope is negative 4 over 4, which is negative 1 meters per second. However, when we talk about speed, for example, you're not going to say, oh, I went to Ottawa and I was going at the rate of negative 100 kilometers per hour. People don't talk that way, right? So we use a positive value for speed, okay? When we have a negative, that's really a velocity. And later on, we're going to talk about all of this because you're giving direction with it. But right now, I'm not concerned about that because I already said I'm going towards. I already gave the direction. So here, I'm just going to say the rate of 1 meters per second. Okay? Do the next example yourselves. Then we're going to take it up. Just make sure that you draw your axes You need to draw your time axis and the distance axis. Don't just label a grid for me. Draw axes. All right. So in drawing this, as we said, first step, you draw your axes, your time and distance axis. Time is independent, distance is dependent. Okay? Now we're gonna look at what the scenario describes. The first one says Leanne starts 10 meters from a motion sensor and jogs toward it. Okay? So I have to label where my 10 meter is, so my scale. So I'm gonna, let's say this is my 10 meters here. Okay? Now I'm gonna show this motion. Starts there, going toward the sensor. Which direction do I go? Do I go upward or downward? Downward. Okay? So because it's toward. Now it says it's jogging, meaning that it needs to be a bit steeper than what you would normally do walking, right? So it would be something like this. Okay, or even if you can go even steeper than that. Okay. So that's how that would look. Second one says Ray stands 5 meters from a motion sensor. So let's say that's my 5 meter. How would I show this? A horizontal line. I saw some of you were putting a point there, a dot. Remember, that's just showing one instant, a point. But if I'm just standing, that means the time is passing by. It's just that my distance is not changing. So I have to show that constant distance of 5 meters throughout. So it is a horizontal line. Okay. Next one, it says Anthony starts 1 meter from the sensor and walks slowly away from it. So which direction am I going? Upward. And because it says it's walking slowly, that means it's not steep at all. So something like that. Okay. So these are one kind of like me asking you to describe motion. Sometimes we get into more like realistic stuff, and based on the units, you can tell what's happening. So let's say I have given this graph. So you can see there is no scale on it. So you can go wild in your description of what's really happening. So you want a story that matches this distance time graphs. So you need to be creative. Okay, so I want you to start thinking of what's happening, what is this describing. Generally, in this type of scenarios, we consider origin as home. So that's where you're starting. So you can describe, for example, you start at home and you were going to your friend's house, or you were going to school, okay? Whatever, right? You were going to a movie theater. So you describe what's happening, okay? So start working on that. Just be creative, but stay legal, okay? Nothing like I went to buy drugs and the cops were chasing me and those. We don't get into that, okay? Keep it legal. Yeah, so essentially, as I mentioned, that you need to mention the distances. So for example, a story for this could be you are going to school, a third of the way you realize that you left your phone at home, so you jog back because it's steeper, so you use jogging instead of walking this time, and then you spend a couple of minutes to find your bag, and then you ran to school. Okay? So right now I want you to do this practice. So here I'm giving you a scenario, and I want you to draw what's happening here. Okay, so first of all, for this one, because the question is referring to like 3/4 of a distance, it would be a good idea to divide our distance into 4 parts. So let's do 1, 2, 3, 4. Okay? So now how would you suggest we do this? So let's read it first. Corbin leaves home on his bike at about 3/4 of distance marked from school. He hits the curb and gets a flat tire. He tries to fix it, but in the end, he has to push his bike to school. So, what do I do? Ava?
You would go upward 3/4 of the distance, like from the Original.
Okay, and am I going steep, not so steep? How am I going?
Like it, not like really steep because it's not like he's like sprinting on the bicycle, but like an average.
Sprint on the bicycle?
No, I mean like going like really fast on the bicycle.
But he's still on the bike, right?
Yeah, so
Than
it's not
being on a.
fast.
So
Not as fast. It's faster than walking, but slower than walking.
okay, good. Slower than sprinting on the bike. Oh God. Okay. So we went up to 3/4 of distance. So it's fairly steep, okay, because it's on the bike. And then it's getting flat tire. So what's happening here? What do I show there? Here? Horizontal line. So that's when he has a flat tire, spending some time to fix it, not successful. Then we want to show pushing the bike to school.
Draw like a line up, but it's like not steep at all because it's pushing the bike.
Very good. So it's still upward because it's still heading school. If I go downward, that means I'm going back home. That's not the case. Well, I need to go to so not steep at all, going to where I had the 4th line. That shows that's the school. So that's how this graph looks like. Okay? So work on the next practice question and then the questions at the back. Also some homework questions posted. So you need to do all of these.